Hey guys, welcome back to chapter 9. What we're going to do now is we're going to start breaking down these solutions into a little bit more details, looking specifically at the molecules that make up our solutions. So what we defined in the last video is that solutions are homogeneous mixtures. They have both a solvent and a solute. So solvent is going to be whatever is in the greatest proportion. Solute is whatever is in the lesser proportion. We're going to break down this solute piece today and look at some of the different properties. So the two types of solutes that we're going to talk about are ionic and covalent. So the solutes can be classified by their ability to conduct an electrical current. So little foreshadowing here, one of these solutes, ionic or covalent, will conduct an electrical current. One of them will not. So that's how we're going to classify these two solutes. But before we can classify them, let's take a look at how ionic and covalent solutes differ. So first thing to remember, what is a covalent compound? A covalent compound is going to be a nonmetal bound to another nonmetal. And when those two come together, what happens to their electrons? Electrons are shared. Okay. In an ionic compound, we've got a metal and a nonmetal. And what happens to their electrons? Their electrons are transferred. So we have those charged particles, those ions, and they are held together by that positive and negative charge being attracted. Okay. So the first thing that we're going to talk about is covalent. So sugar is an example of a covalent compound. So sugar is a bunch of carbons, hydrogens, and oxygens all bound together. So all three of those elements are nonmetals. We know electrons are being shared. The other thing we know is that sugar does in fact dissolve in water, right? Back to sweet tea. So you put a little bit of sugar in water, you stir it around, and it will dissolve in that water. So we know that it dissolves in water. When sugar dissolves in water, it does so by not dissociating. So that word dissociate is just a fancy pants word for break apart. So sugar and all other covalent molecules do not break apart when we put them into solution. So here's a picture of that. This big molecule in the middle here is our sugar molecule. And then these little ones on the outside are our water molecules. So when I put a sugar molecule into solution, it does not break apart. It stays together as this big honkin' molecule. What causes it to dissolve are these interactions with water. And these interactions are a little bit beyond this class. But just know that it does interact with water and it does dissolve in water. But the big take home here is it does not dissociate, it does not break apart. Conversely, we've got ionic compounds. So remember, ionic is a nonmetal in metal. Electrons are transferred. We have charged particles. Our poster child for ionic is salt, sodium chloride. And if we think about salt, we also know that salt will dissolve in water. So we live by a huge body of salt water. We don't see the salt in that water, but we know it's there. If you dump a little bit of salt into water as you're cooking and stir it, we know that salt will dissolve in water. So salt dissolves in water. When salt and any ionic compound dissolves in water, it will dissociate in water. Remember, that's just a fancy word for it will break apart when it dissolves in water. So here's what salt looks like when it dissolves in water. So these green and purple dots are sodium chloride. So remember, sodium is a positively charged ion, chlorine is a negatively charged ion, and they're all stuck together. But when we put salt into water, what happens is the sodium will interact with water molecules. So the water will surround the sodium, and we'll see that that sodium ion will break apart over here. And then water will interact with these chlorine ions, and this chlorine ion will float away over here. So once this is completely dissolved in water, what we'll see is a bunch of positively charged and negatively charged ions all floating around in the water. That's called dissociation in water, breaking apart in water. Okay. So as I said, solutes can be classified by their ability to conduct an electrical current. So looking at these two examples, so our sugar stays together as one big molecule. Our salt dissociates into charged particles. Which one do you suspect is going to conduct electricity? Okay, let's take a look. So here we see an experiment. What we have going on here is a light bulb with two electrodes that are in water. And then we've got another wire here. So an electrical current would flow into the water on this wire. If the water conducts electricity, it would jump through the water, across the water to this other electrode and light our light bulb. If it does not conduct electricity, then it will not pass from one electrode to the other, and therefore our light bulb will not light. So here we see our sugar example. So sucrose is sugar. Here we see our sugar example, and we see that the light bulb is not lit. With the light bulb not being lit, that tells me that this does not conduct electricity. So we call that a non-electrolyte. So covalent molecules do not dissociate. They stay together as one big molecule, and they do not conduct electricity in water. Okay. Let's look at the other side of the spectrum here. So here we see salt dissolved in water. We see the same setup. So electrical current comes in, electrode, water, electrode. Here, we see that that current did go from one electrode to the other and did, in fact, light our light bulb very brightly. So what that tells me is that when salt dissolves in water, those charged particles will allow electricity to flow. So ionic compounds do conduct electricity. So ionic compounds dissociate in water, and they do conduct electricity. If you guys know anything about electrical currents are really just a flow of electrons. So with these charged particles in solution, those electrons have places to jump from charged particle to charged particle to get to the other electrode. Okay. Well, hopefully you know this about science, but science is not black or white, right or wrong, yes or no. There's always a gray area in the middle. So a non-electrolyte is going to be our covalent compounds. They do not conduct electricity. An electrolyte is something that does conduct electricity. There's also this gray area where it is an electrolyte. So it does conduct electricity. But what do you notice about the middle light bulb and this light bulb on the right? The middle light bulb is very dim. The light bulb on the right is very bright. So both of these do technically conduct electricity. This guy on the right just conducts it a little bit better. So here we have the difference between a weak electrolyte, dim light bulb, strong electrolyte, very bright light bulb. The difference, if we look at the molecules, is this. In a strong electrolyte, we see that every particle of sodium chloride is broken apart. So we see 3 sodiums, 3 chlorines, everything is dissociated or broken apart. In a weak electrolyte, we see some of the particles have broken apart. So here's one where we have a hydrogen and a fluorine broken apart. But for whatever reason, some of the particles choose to stay together. So does this conduct electricity? Well, yeah, there's a few charged particles here, but it doesn't conduct it as well because some of the particles stay together. There's not as many particles in there for the electrons to jump to and from. Okay, so non-electrolyte does not dissociate. Weak electrolyte dissociates a little bit. Strong electrolyte completely dissociates. And on this slide, you'll see those words. So the last thing, before I wrap up this portion of the chapter, where have you seen that word electrolyte before? Well, you've probably seen it on things like Gatorade and Powerade, right? So Gatorade and Powerade market this idea of replace your electrolytes when you exercise. So when you exercise, you sweat and you excrete things like sodium chloride, salt. You also excrete other ions like potassium and magnesium that if you work out really, really hard for a long time, you will need to replenish those. So, of course, Gatorade uses this fancy science word to promote or market their products. Does that Gatorade also contain some non-electrolytes? Yeah, it does. So that Gatorade also has sugar, lots and lots of sugar. But do they promote that sugar, that non-electrolyte? No, they don't. But there are also non-electrolytes in that Gatorade as well. So just somewhere that you've seen that word electrolyte before, that's what they're talking about when they market those electrolytes. It's just the ions that you need to replace when you work out really, really hard. So that wraps up this portion of the chapter. We've got one more small video on the way, and then that will be it for chapter 9.